Welcome to our beginner's guide to quantum physics. In this video, we'll embark on a fascinating journey into the quantum world where the rules of classical physics no longer apply. Whether you're curious about the mysteries of the universe or just want to understand the basics, you're in the right place. We'll start by exploring what quantum physics is, why it matters, and how it shapes our understanding of reality. Get ready to discover concepts that challenge our everyday experiences and open your mind to new possibilities. Let's dive in and unravel the secrets of the quantum realm together. Quantum physics is the branch of science that studies the behavior of matter and energy at the smallest scales, think atoms and subatomic particles. Unlike classical physics, which explains the world we see every day, quantum physics reveals a universe that's unpredictable and full of surprises. In this scene, we'll break down the basics of quantum theory and explain why it's so different from what we're used to. By the end, you'll have a clearer idea of what makes quantum physics so unique and important. Let's travel back in time to the early 20th century, when scientists like Max Planck and Albert Einstein began to question the limits of classical physics. Their groundbreaking experiments showed that energy isn't always continuous. It comes in tiny packets called quanta. This discovery marked the beginning of quantum theory and set the stage for a scientific revolution. In this scene, we'll explore the key moments and people who shaped the foundation of quantum physics. One of the most mind-bending ideas in quantum physics is wave-particle duality. This concept tells us that particles like electrons and photons can behave both as particles and as waves, depending on how we observe them. It's a phenomenon that defies our everyday logic but has been proven in countless experiments. In this scene, we use simple examples to help you grasp this strange but fundamental aspect of the quantum world. Next, we'll look at the famous uncertainty principle, introduced by Werner Heisenberg. This principle states that it's impossible to know both the exact position and momentum of a particle at the same time. The more precisely we know one, the less we know about the other. This isn't just a limitation of our measuring tools, it's a fundamental property of nature. We'll explain what this means for scientists and why it's so important in quantum physics. Superposition is another key idea in quantum physics. It means that particles can exist in multiple states at once until they are measured. Imagine a coin spinning in the air, it's both heads and tails until it lands. In the quantum world, this isn't just a metaphor, it's reality. We'll discuss how superposition leads to some of the most famous quantum experiments and why it's so crucial for technologies like quantum computing. Quantum entanglement is a phenomenon where two particles become linked, so that the state of one instantly affects the state of the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. Entanglement challenges our understanding of space and information. In this scene, we'll break down how entanglement works and why it's one of the most intriguing mysteries in quantum physics. Double-slit experiment is a classic demonstration of quantum weirdness. When particles like electrons are fired at a barrier with two slits, they create an interference pattern as if they're waves passing through both slits at once. But when we observe them, they behave like particles. This experiment shows how observation changes reality at the quantum level. We'll walk you through the setup and what it reveals about the nature of matter and light. Quantum tunneling is another phenomenon that defies classical logic. In the quantum world, particles can sometimes pass through barriers that should be impossible to cross. This effect is crucial in many technologies, including semiconductors and nuclear fusion. We'll explain how tunneling works and why it's so important for both science and everyday life. Quantum physics, the act of measurement, plays a special role. Before we measure a particle, it exists in a superposition of states. But the moment we observe it, the superposition collapses into a single outcome. This is known as the measurement problem, and it's one of the most debated topics in quantum theory. We'll discuss what this means and how it shapes our understanding of reality. Schrödinger's cat is a famous thought experiment that illustrates the strangeness of quantum superposition. Imagine a cat in a box that's both alive and dead until someone opens the box and checks. This paradox highlights the weirdness of quantum measurement and challenges our ideas about reality. We'll explain the story and what it teaches us about the quantum world. Quantum numbers are used to describe the properties of particles, such as their energy, spin, and position. These numbers help scientists predict how particles will behave in different situations. In this scene, we'll introduce the main types of quantum numbers and explain why they're essential for understanding atomic structure and chemical reactions. Spin is a unique property of quantum particles. Unlike spinning objects in our everyday world, quantum spin doesn't refer to physical rotation. Instead, it's a fundamental characteristic that affects how particles interact with each other and with magnetic fields. We'll break down what spin means and why it's so important in quantum mechanics. The Pauli exclusion principle states that no two electrons in an atom can have the same set of quantum numbers. This rule explains why atoms have their unique structures and why matter is stable. We'll discuss how this principle shapes the periodic table and the world around us. Quantum physics isn't just theoretical, it has real-world applications. Technologies like lasers, MRI machines, and transistors all rely on quantum principles. In this scene, we'll highlight some of the ways quantum physics has transformed technology and improved our daily lives. Quantum computing is one of the most exciting frontiers in technology. Unlike traditional computers, which use bits, quantum computers use qubits that can exist in multiple states at once. This allows them to solve certain problems much faster than classical computers. We'll explain how quantum computers work and what they could mean for the future. Quantum cryptography uses the principles of quantum physics to create secure communication systems. Because quantum states can't be copied or measured without detection, this technology promises unbreakable encryption. we'll discuss how quantum cryptography works and why it's so important for data security. Quantum teleportation isn't about moving objects instantly from one place to another like in science fiction. Instead, it's a process where the state of a particle is transferred to another particle at a distance, using entanglement. This technology could revolutionize communication and computing. We'll explain how quantum teleportation works and what it could mean for the future. Did you know that quantum physics also plays a role in biology? Some processes in living organisms like photosynthesis and bird navigation may rely on quantum effects. In this scene, we'll explore the emerging field of quantum biology and how it's changing our understanding of life itself. Despite its successes, quantum physics still has many unanswered questions. From the measurement problem to the nature of reality itself, scientists continue to debate and explore the mysteries of the quantum world. In this scene, we'll highlight some of the biggest challenges and open questions that keep researchers busy. As we wrap up our journey, let's look ahead to the future of quantum physics. With new discoveries and technologies on the horizon, the quantum world promises to keep surprising us. Whether it's breakthroughs in computing, communication, or our understanding of the universe, quantum physics will continue to shape our world in ways we can only imagine. Thank you for joining us on this adventure into the quantum realm.